Assalamualaikum and hi everyone. Let's continue with chapter 9. Chapter 9 is an extension of equilibrium in the static model. In other words, this is the second part of equilibrium in the static model. In this chapter, we're going to see what happens to output and also other economic variables when economic policies is carried out. There are two different types of economic policies that you have learned before, but in different manner. The first one is fiscal and the second one is monetary policy. But first, let's look at revision. I'm sure all of you have seen expression 1 until 4, and these expressions can be divided into two sides of the economy. The first one is the demand side of the economy, and the second one, which is expression 3 and 4, is the supply side of the economy. On the demand side of the economy, we have IS and LM schedule. IS is referring to expression 1. LM is referring to expression 2. IS here shows you equilibrium in the product market. Whatever being produced has to be equal to whatever being spent. Whatever being produced refers to real output. Whatever being spent refers to consumption, investment, and also government spending. On the other hand, we also have LM. LM shows you equilibrium in the money market. That means money supply on the left-hand side must be equal to money demand on the right-hand side. On the supply side, we have two different things. The first one is labor market and the second one is production function. If you see expression 3 here, it shows you equilibrium in the labor market. On the left-hand side, we have nominal labor demand. On the right-hand side, we have nominal labor supply. As you can see here, labor demand is attached to actual price. Labor supply is attached to expected price. There is a relationship between expected price and also actual price. What kind of relationship? It is expressed in this term. As you can see, small letter p prime has to be positive and between 0 and 1. Can you recall back small letter p prime is nothing else but this, delta PE over delta P, and it has between 0 and 1. Okay? If there is an increase in actual price by 1 unit, how much is the increase in expected price? The increase in expected price is between 0 and 1, and that means it has to be positive. Lastly, you also have seen production function in expression 4. Production function in expression 4 on the left-hand side is the real output, and this real output depends on two things. The first one is employment, and the second one is capital. Note that capital is fixed because of this bar sign, and that means the production function is for short run period. So let's continue with economic policies. So we start with Keynesian case. We know that we have two different types of economic policies, fiscal and also monetary policies. So we look at fiscal first. And in fiscal policy, we have two different tools, namely government spending, G, and also taxes, tau. Let's look at expansionary fiscal policy, and we use G as a tool. Therefore, we have an increase in G. All of this can be easily explained using four different graphs. The first graph is IS-LM schedules. The second graph is ADAS. And the third graph is nominal labor market. And the fourth graph is production function. So here, there is an increase in G. Okay, expansionary fiscal policy. Therefore, IS will shift to the right from IS0 to IS1. So we shift the IS0 to IS1, it's going to look like this. Okay, so the new one is IS1. Why IS has to shift from IS0 to IS1? Because G is a direct component of IS. Now, if we maintain our interest rate at R0, then we can see output can be expanded to Y3 here. Okay, let's say Y3 is here. However, this is disequilibrium. As income increases from Y0 to Y3, that means households in the country will need more money to purchase goods and services because now they have more income. Now money demand will increase with the increase in income from Y0 to Y3. That means we are having movement along the LM curve from point A to point B. Then you can see output, instead of increase from Y0 to Y3, it increases to Y2. Okay, then you can see interest rate increases from R0 to, let's say, R2 here, but I just don't want to miss the graph. Okay, now on the other hand, if we look at AD and AS analysis, when there is an increase in G, AD will shift to the right. The same reason, because G is a direct component of aggregate demand. Okay, so now AD shift to the right from AD0 to AD1. So if we maintain the price at P0, then you can see output can be extended or increased from Y0 to Y2. Okay, but because there's adjustment, because you can see clearly we have this equilibrium here, then price will help to adjust in the market. Then price increases here from P0 to P1. Therefore, output only increase from Y0 to Y1. And we have new equilibrium point here, B prime. Now, what happens to the nominal labor market? Previously, we have seen price increased from P0 to P1. As you can see, labor demand is attached to the actual price, P0, and we already know price increased from P0 to P1. Therefore, it is very obvious to see that labor demand will be affected. So, labor demand will increase and shift to the right from P0 Fn to P1 Fn. So, we can draw it like this. Okay, P1 Fn. Okay, so you can see employment increases from N0 to N2. So when employment increases from N0 to N2, so here we have the new equilibrium point, we call it beta. Then we can also see it happens here in the production function, N0 to N2, and then output increases to Y2. Here we have increase in alpha prime to beta prime. Okay. Now, when price changes, it takes time for expected price to change. And remember, this is Keynesian case. The price won't change one-to-one. So when price increases, we can also see here nominal wage increases from W0 to W2. Yeah. And then household feels that they receive more income in nominal term. But when actual price has increased, they didn't realize it, but they realized that when nominal wage increases, they could expect the price would increase. So they adjust their expectation. When they adjust their expectation, the expected price increases. Increase in expected price will then affect real wage. Then they know that their real wage will decrease. The purchasing power to buy goods and services in the market now becomes lesser. Then this demotivates them to work more. As a consequence, we can expect the labor supply to decrease or shift to the left from PE0 GN to PE1 GN. Now, so we move the labor supply to the left. Okay, so this is PE1 GN. So you can see the new equilibrium is here. Employment doesn't expand more here. It expands, but it only expands from N0 to N1. So call this one as C and then this one as W1. And here also N1 and here Y1. Okay, so now we can see that output only increases from N0 to N1, Y0 to Y1, but not to Y2. So now we can summarize the whole analysis like this. So first, in the initial stage, we have R0, Y0, as well as N0, W0 nominal wage, and also we also have real wage, which is equivalent to capital W0 over P0. Yeah, we have P0. But then finally, what do we have? We have R1 such that R1 is bigger than R0. We have Y1 such that Y1 is also bigger than Y0 in it. We also have W1 real wage. We also have nominal wage W1. And we also have P1. Try to see whether they are bigger or less or equal to the previous, variables. Let's continue with monetary policy. Let's assume that we have an expansionary monetary policy. This means real money stock or money supply increases. As a consequence, LM schedule will also increase or shift to the left. This can be shown in the graph as this. So LM schedule will shift to the right from LM0 to LM2. The new intersection will be at point B, and the new interest rate will fall from R0 to R2. And as a consequence, real output increases from Y0 to Y2. Now, what's the intuition behind this result? When interest rate falls down in the economy, that means the cost of production decreases. This leads to an increase in investment, okay, because interest rate is also cost of investment. So when investment demand increases, then production starts to increase. This means output increases and we have economic growth. That is why output increases from Y0 to Y2. Not only that, because of some part of it has some multiplier effect, consumption also increases, and so on and so forth. As a consequence, you can see as investment increases, we are basically referring to movement along the IS curve, and this is a movement along the IS curve or schedule due to change in interest rate. Now, not only that, this has some implication on AD and AS schedules or curves. Recall back when interest rate falls down, investment increases. And we already know that investment is also a direct component of AD not only IS. So as a consequence, we can say that AD naught can also shift to the right. So let me draw it here. So aggregate demand shift to the right from AD naught to AD1. If we fix the price fixed at P naught, then you can see output is extended to, let's say, Y2. Nevertheless, this is disequilibrium, so adjustment has to be carried out. So after adjustment, price increases from P0 to P1. The new equilibrium will be at point B prime, and output falls from Y2 to Y1. However, you can see the net change in output is an increase in output from Y0 to Y1. Price increases, interest rate falls down. Okay, now if we see here, price has increased from P0 to P1 due to the increase in aggregate demand. Now when price increases, if you recall back LM, it is basically money supply equals to money demand, isn't it, in real term? Okay, so when price increases, all right, it decreases the ratio of equilibrium in LM. That means, okay, LM has to shift to the left from LM2 to LM1. So here to LM1. Let's call this new equilibrium point as point C. We can see that output decreases from Y2 to Y1. And finally, interest rate from R2 to R1. So you can see the net change in income is still an increase from Y0 to Y1. And the price of investment, which is interest rate, has decreased in net from R0 to R1. Now the analysis continue in labor market as well as production function. So here we have nominal labor market. So recall back in the AD and AS schedule or curves, we have an increase in price from P0 to P1. So obviously in the labor market, because actual price has increased from P0 to P1, it will directly affect the nominal labor demand here. Okay, so what happens to labor demand is that it will increase or shift to the right. So let me draw it here. It will shift to the right from P0 Fn to P1 Fn. As a consequence, we can see nominal wage increases from W0 to W2, and employment increases from N0 to N2. Because employment increases from N0 to N2, in the production function, we can see output increases from Y0 to Y2. So we have new point here, call it beta prime. Here, beta. Now, in Keynesian case, when actual price increases, household, they may have a little bit of information about the increase in actual price, but that one can be seen after certain time, not immediately. So after certain time, they can feel that, okay, price has increased. So they need to adjust the expectation on the expected price. When they adjust their expectation to the expected price, what kind of expected price they will adjust here? They will adjust in such a way that they feel expected price has to be increased as well. So when expected price is adjusted to be increased, that means expected real wage, which is given by the nominal wage divided by expected price, will fall. This also means purchasing powers of household falling. Now, they will feel that for the same labor hours they supply, they have lesser real income and lesser purchasing power. As a consequence, they have less motivation to work more hours and therefore they reduce the labor supply. So when they reduce the labor supply curve in nominal term has to shift to the left. So let's say it shifts to the left like this. Okay, so we have PE1 GN. So as you can see, if you draw carefully here, employment falls from N2 to N1 and nominal wage keeps increasing to W1 from W2 to W1. And the last point of equilibrium in the labor market is given by this, given by C. So because employment has reduced from N2 to N1, in the production function curve, we have N1 here. And then we can see clearly output is reduced from Y2 to Y1. First, it increases and then it decreases. So this one, call it C prime. Okay. So we move now to classical case. So we look at the first one, fiscal policy. In classical case, we already know that price is flexible. Therefore, if there's an increase in actual price by 1, there will be adjustment in expected price by 1 also. So that means there is 1-to-1 adjustment between actual price and also expected price. So now let's start with fiscal policy. So let's say we have the same thing. There is an increase in G, okay, or government spending. Because G is a direct component of IS, so we know that IS will shift to the right from IS0 to IS1. So let's say it looks like this. So now we label it as IS1. As you can see here, it's very clear that the output will increase from Y0 to this, Y2 for instance, and interest rate increases to R1. Let's call this new point as point P. So what happens in the aggregate demand and also aggregate supply curves? Here, as you can see, there's an increase in G, also means increase in AD. Why? Because like I said earlier, G is a direct component of AD. Okay, so AD will shift to the right as well from AD0 to AD1 like this. So we label it as AD1. If you hold price constant at P0, you can see that the output will be extended to Y2. Nevertheless, we can see this equilibrium here between this Y0 and Y2. So adjustment will take place in AD and AS analysis. So what happens here is that price will go up from P0 to P1. Okay, so we reach to the new equilibrium, we call it point P. Okay, now as you can see, Y0 will increase to Y1. Sorry, Y2 will increase to Y0. As price increases from P0 to P2, you can see that in LM equilibrium, price increases, so the whole thing will decrease. When the whole thing real money stock in the country decreases, that that obviously affects LM. So LM will shift to the left. So when LM shift to the left, it will shift like this. You check the way I draw it here. From LM0 to LM1. Okay, and we can see that the interest rate increases further to R2, but the output goes back to Y0. Okay, so this is done. But what happens to labor market and also production functions? So we move to the second one here. I said earlier, if we can recall back, price has increased from P0 to P1. So when price increases from P0 P1 to P1, in the labor market, it is very clear that the first thing that will be affected is labor demand. And this refers to nominal labor demand. So here what we can do is that to shift the nominal labor demand to the right. So this is how it looks like. So now it shifts from P0 Fn to P1 Fn. Okay, so here you can see that we have new employment. If we fix the nominal wage at W0, you can see employment is increased to from N0 to the new level here, but I don't want to mess it up. And then we can have a new equilibrium, which is here. I call it point beta here. And the new equilibrium will be here. Call it, let's say, N1 or N whatever. And here is W1. Okay, but at the same time, in the production function, okay, you can see that, okay, the employment will increase also from N0 to N1. And then the output will increase from Y0 to Y2. So Y2 is here. So in summary, what we can see here is that price increases, okay, output stay the same, employment stay the same, interest rate increases. From what to what, you have to recheck again all the graphs that I've already explained to you earlier. So we are done with fiscal policy. Now let's continue with monetary policy. Let's say in the classical case here, we have an increase in money supply. Now in this case, if there is an increase in money supply or money stock, so recall by equation, money supply increases. Okay, when money supply increases, real money supply increases. Okay, and then it will increase the LM to the right. Let's say from LM0 to LM1. We can see here interest rate falls down to R1 and output increases to Y1. Now, as output increases to Y1, okay, here aggregate demand also shift to the right. Why? Because when money supply increases, therefore interest rate falls down and then the cost of production decreases and investment demand will increase. When investment demand increases, that means AD shift to the right. Why? Because investment demand is a direct component of AD. Okay, so we have movement along the IS curve. When interest rate falls down, investment demand increases. That leads to increase in output. But here in the AD, it is shifting to the right. Okay, so from AD0 to AD1. If price is kept constant, then we move here. Okay, from Y0 to Y1. But because of the adjustment in price, because otherwise we're going to have a persistent disequilibrium in the ADAS analysis, so price has to adjust. So price adjusts and increases to P1. So we move to the new equilibrium P prime called from A prime to B prime. Okay. Now, when price increases, initially you see money supply increases, but at the same time now, price increases. So the whole thing here will go back to original. That means first this one increase and then this one increase as well. So there is no change in the proportion of M over P. Therefore, that means M will shift to the left again. Now, we move to labor market. When price increases from P0 to P1, obviously it will affect labor market. Which curve? It will affect labor demand. So labor demand will shift to the right from P0 Fn to P1 Fn. Okay, if we fix the nominal wage at W0, you can see employment will increase to N1. So it'll shift here, N1. And therefore, in the production function, we can have Y1. We move to beta prime here. This one is beta. But because in the classical case, we have P prime, which is equivalent to delta PE over delta P equals to 1. Therefore, if actual price increases by 1 unit, expected price will also increase by 1 unit. So what's the consequence of this assumption? So when actual price increases by 1 unit leads to the increase in expected price by 1 unit, after the adjustment in expected price, household will feel that their real wage will go down. So as you can see here, expected price increases, so the whole thing decreases in it. So household feels that when real wage decreases, they don't want to supply more labor hours because for each labor hour they supply, their income become lesser than before. So we should expect in the labor market, labor supply will decrease to the left from PE0GN to PE1GN. So be careful when it comes to drawing. The shift has to be like this. Okay, PE1GN. So as you can see, if this one is somehow N2, okay, it will even shift further to the left to N0. So the new equilibrium should be here, call it C. Now it moved back to N0. Here we can see that in classical case, real variables do not change. You can see employment stay the same at N0, okay, so no change. Output stay the same at Y0. Nevertheless, we can see that nominal wage increases. We can also see that price increases, but no change in interest rate because LM shift back to its original situation or location. We have seen fiscal and monetary policy in the static model in the form of graphs. Now we move to the mathematical expressions. So we want to look at fiscal and monetary multipliers in the static model. Let's recall back equation 14 in chapter 7, that is this. This is actually the slope of aggregate supply curve, dy over dp. It consists of the slope of production function, the relationship between price and also expected price, the slope of supply of labor, and the slope of labor demand. Okay. Let's say we want to inverse dy over dp, therefore it becomes dp over dy. Okay. So this is still the slope of aggregate supply function, but we just inverse it. Now, we want to see the relationship between the slope of aggregate supply function or curve with dp e over dp or delta P over delta capital P. So I bring the equation here so that we can compare. Look at this term. This term is situated in the denominator of this expression. This term, if you can recall back, is nothing else but P prime. P prime in our previous lecture note is written as delta PE over delta P. Okay? Now, P as a function of actual price. Okay, let's imagine if delta small letter p here over delta capital P approaches 1. So the whole thing here will be almost 1. 1 minus 1 becomes 0. Now, if the denominator value is 0, then the whole expression here will be almost infinity. So we can have the slope of aggregate supply infinity. That means if we draw it in the form of graph, then it looks like this. So we have price here. So this is our AS. This shows the AS or aggregate supply curve for classical model. Okay. In classical, this one is equivalent to 1. On the other hand, if we try to have this term approaches 0, then 1 minus 0 is 1. Therefore, denominator has certain value which is not equal to infinity or minus infinity. Then the whole value of delta P over, dP over dy should be positive. How do we know? Delta y over delta n is positive. The higher the employment, which is n, the higher the output we can produce, which is y. Okay, so this one is positive. Delta G over delta N is actually the slope of labor supply. Labor supply is positively in terms of slope, and this one, delta F over delta N, is the slope of labor demand. The slope of labor demand is negative or minus sign. Positive, and then we have negative here means negative, it becomes positive. So the whole thing on the numerator here is positive. Positive, positive, then the whole dP over dy is positive. So if dP over dy is positive, then we can have AS, which is upsloping. Now this refers to Keynesian case. Okay, the second case here refers to Keynesian case. The first case here refers to classical case. Well, as you can see, for the slope of aggregate supply, which is dP over dy here, okay, the price change enters the multiplier through its effect on the interest rate in the money market. So logically speaking, okay, let's say there is an increase in money supply. You know that as we have seen earlier, LM will increase. When LM increase, interest rate falls down. Because interest rate is the cost of borrowing, then investment increases because now the cost of borrowing is relatively cheaper. And because investment is a direct component of aggregate demand will shift to the right. Okay, so let's say here AD to AD prime. And also the same case for classical. So you can see price increases. Here also the same thing. Alright. So here it shows you the movement along the AS curve also. Okay. Next, we want to look at multiplier for changes in government purchases. In this new multiplier, we will see a difference. Why? Because in this multiplier, price now is allowed to vary. So let's recall back, we have IS and LM in expression 1 and 2. We also have nominal labor market in expression 3, such that P prime or the relationship between expected price and also actual price must be between 0 and 1. Lastly, we have production function given by expression 4. What we should do now is to totally differentiate the IS schedule or curve to obtain expression 7. So expression 7 is not something new for you because this has been repeated in the previous chapters many times. Okay, now recall that we also have LM schedule. So what we need to do is to totally differentiate LM schedule. And this time be careful because we allow price P to vary, but we hold money stock constant. Okay, so how do we do it? So we have D M over P equals to what? It is P square underneath here, and then we hold price constant, but we try to change money stock here, minus we hold money stock constant, but we allow price to change, and then equals to the rest here. Okay, if you look at this, okay, this is DM or the change in money stock, but as we see that we need to hold money stock constants, therefore DM or the change in money stock should be 0. When DM is 0, then it implies PDM is actually 0. That's why we are left with this bit. Okay, so we have minus M over P squared dP equal to the rest. And I hope you know how to do the right hand side here. Okay, next we need to rearrange equation at 8 so that we can get something like 9. So rearrange equation 8 such that you put dr on the left hand side and the rest of the variables on the right hand side. Can you see that in expression 9? Can you see that in expression 9, we have two things that can affect interest rate, real output as well as price. In the previous analysis, we don't see the change in price, but now we can see the change in price affecting interest rate. But we must remember our main objective is to find government spending multiplier. So what we need to do is that we will need to substitute change in PODP in expression 9. How do we substitute it? By putting AS slope in expression 9. So let's recall back AS slope. We want to obtain the formal expression of AS slope. We know that AS slope is given by expression 10. In expression 10, the change in output leads to the change in price, and the relationship is positive here. But here we can rewrite expression 10 into 11. How? We just need to cross multiply dy on the left hand side to the right hand side here. So that's why you can see only dp on the left hand side now. Dy has been brought to the right hand side, and this is 11. Okay, we can say expression 9 again here because I put it here so that it's much easier to refer to. Like I said earlier, we will substitute dp in expression 9 This is the DP in expression 9 by what? By the expression of AS loop. Which expression of AS loop? The expression of AS loop in 11 here. So DP here will be substituted by this thing. Okay? So once we substitute it back into expression 9, then we can have expression 9 as expression 12. Okay? So what we need to do, substitute dp into expression 9 and then see the common factor. The common factor is dy. Factorize the right hand side so that you can obtain expression 12 here. This is not the end of the analysis because recall back, we want to find this government spending multiplier. Okay, now I bring back equation 7 in this slide so as to facilitate us in deriving fiscal or government spending multiplier. Okay, what we need to do now is to use equation 12 that we obtained just now in equation 7. In particular, we can see dr in equation 7. So we need to substitute this dr with dr in equation 12. Once we substitute it, rearrange it until we get 13 here. The calculus, you have to do it on your own. Now, let's look at 13. On the left-hand side, we have dy or the change in output or real income. On the right-hand side of equal sign, we have two things. The first one is 1 over something here, and the second one is dg. So, how to interpret this fiscal multiplier? If there is an increase in dg by certain amount, income will increase by what amount? By the whole 1 over all values in the denominator here. So 1 over the whole thing here is basically fiscal multiplier. Now, I bring the equation or expression 13 here, and what we need to do is that we need to look at 13. What happens if price is flexible? If price is flexible, then the fiscal multiplier will look like 13. But what happens if price is fixed? When price is fixed, that means there is no change in price. When there is no change in price, dp is equal to 0. When dp is equal to 0, the whole terms after the plus sign here will be equal to 0 as well. Then, the multiplier in 13 will be equivalent to dy equals to 1 over the whole thing on the denominator except this, and then multiply by dg. So now we can see there are two different types of multiplier. The first one, when dp exists. When dp exists, this term also exists. The second one is when dp is 0. When dp is 0, that means the price is fixed. Then the multiplier will be without this term. So which condition gives bigger multiplier? Is it the one with flexible price or the one with fixed price? Obviously, when the price is fixed, this term doesn't exist, and therefore mathematically multiplier will be bigger for the fixed price case. However, what is the economic intuition behind equation 13? This can be explained using the graph here. So let's say we have price on the vertical axis and also real income on the horizontal axis. Let's say we put all three different types of aggregate supply segment into one graph like this. So you can see the horizontal segment here, and then suddenly we have upsloping segment, and then we have vertical segment of AS. The vertical segment of AS is for classical case. The upsloping and also the flat case is for Keynesian. Now, let's start with AD. So AD is here. With the current income, why not? Okay. Therefore, AD here is in the range of horizontal AS curve. Just imagine if we have, shift in AD to the left. Let's say from AD to AD naught. Then we can see in this range, price is at P naught. When income is at Y naught, price is at P naught. When income decreases due to decrease in AD from AD to AD naught, then income decreases to, let's say, Y prime. So this is the total change in income. Now, given that the price is flexible, the total change in income will be by the full amount of government spending multiplier or fiscal multiplier when dP is equals to 0, isn't it? Now, let's move back to AD. Now, let's assume that AD shift to the right. When AD shift to the right from AD to AD prime here, we can see income increases to Y1. Still, we can see that the shift is within the horizontal segment of AS. So this is the change in income. The change in income here is basically by the full amount of multiplier as well, because no change in the price. However, if we are in the upsloping segment now, let's say AD1 now shift to AD2, then we can see the equilibrium is here, and not only income changes from Y1 to Y2, but price also changes or increases from P0 to P1. Let's say from AD1 to AD double prime, here we fix the price at P0. Therefore, income can actually increases to, let's say, Y3. However, when price is flexible, price has to adjust so as to reduce the existence of disequilibrium. So income increases only from Y1 to Y2. Now, in this case, dP is not equal to 0. dP is actually bigger than 0, or there's an increase in price from P0 to P1. Hence, the government spending multiplier is actually 13 because dP over dy exists. dP gives effect on dy. In other words, change in price gives impact on change in y. What kind of impact? Adverse or negative impact. Graphically, this negative impact can be seen by the reduction in output from Y3 to Y2. However, let me emphasize here, the net change in income or output is still there from Y1 to Y2. Okay, now let's move on. Let's say currently our AD is at AD double prime. Therefore, the price is at P1 and the income is at Y2. Let's say there is an increase in AD from AD double prime to AD triple prime here. So move to the right further. Current price before the change is P1. If we fix price at P1, output can be expanded to, let's say, Y4. However, you can see clearly here this equilibrium. So the price has to adjust. Remember now we are in the vertical segment of AS, which is referring to the classical segment. So when the price adjusts, we can see that the price increases further from P1 to P2. And after the adjustment in price, output will go back to Y2 from Y4. So is there any change in output in this case? The change in output is actually 0. Why? Because the increase in price from P1 to P2 diminishes the change in output. That means in this case, fiscal policy is ineffective. So we can see that in 13, when DP is not 0 or change in price is there, then the fiscal or government spending multiplier will be smaller. When the government spending multiplier becomes smaller due to the existence of change in price affecting output, the increase in output will be smaller as well compared to when DP is 0. Now we move to the multiplier for changes in tax rate. Tax is another type of fiscal policy tool. Now we want to look at tax as a function of income. That is given by expression 14. T, capital T here equals to small letter t times y. And small letter t here is the tax proportion, which is between 0 and 1. Because we adopt this kind of tax function, then the IS schedule becomes 15. You look at IS schedule here, we have disposable income in which y minus ty. Okay. Now from 15, we want to obtain tax multiplier. Okay. We want to obtain tax multiplier such that price is allowed to vary. So we need to incorporate the AS slope. We also need to incorporate the LM schedule into the derivation of multiplier for changes in tax rate. You should get the following answer, which is in expression 16. Again, I repeat, in order to obtain multiplier for changes in tax rate, you need IS schedule, second, you need LM schedule, and the third, you need AS slope function. Okay. We have seen AS slope function when we tried to derive fiscal or government spending multiplier previously. So use all of this information to obtain 16. Again, 16 is what? 16 is multiplier for changes in tax rate. Now, look at 16. On the numerator, we have minus sign. Okay. Now, on the denominator, we have this term. All of these terms, when we try to figure out the sign has to be positive. Therefore, minus on numerator, plus on the denominator, then the whole thing becomes minus. So what does it mean here? If there is an increase in tax rate, income will decrease. Okay. But here we have incorporated the change in price. Now, if the change in price is not 0, then the multiplier for changes in tax rate is 16. However, if the change in price is equivalent to 0, then the whole term here will be vanished. And the whole multiplier here for changes in tax rate will be similar to the one that we have seen before in previous chapters. Now, when we allow price to change, what's the impact of the change in price on fiscal policy when we use tax as the tool. Obviously, it gives, smaller impacts on the change in income. So, let's say tax increases by 10% in terms of rate. If there is no change in price, the decrease in income would be bigger than when the change in price is allowed. So that means the multiplier for changes in tax rate when price is allowed to vary or price is flexible is smaller than the multiplier for changes in tax rate when the price is fixed. Now, we move to multiplier for changes in money supply. This time, we also allow price to vary. So, price is allowed to vary. That means price is flexible. So, how to obtain multiplier for changes in money supply? Of course, we need to utilize LM schedule. Now, we totally differentiate LM schedule like the way I taught you previously, but this time allow the price to vary. Okay? And then we rearrange the results such that DR on the left hand side and the rest on the right hand side. Then you can obtain 17. However, 17 is not the multiplier. We need to do further. And then we use 17 in 7, okay, in IS function that has been totally differentiated to obtain 18. But at the same time, not only IS, we also need to have as slope function to allow price to vary. So here, in order to derive multiplier for changes in money supply, first you need LM schedule, second you need IS schedule, and the third you need aggregate supply slope function to obtain 18. So please do all of this to derive 18 on your own. Now, what's the economic intuition behind this derivation here? Now, you look here. We have three different terms. The first term, the second term, and the third terms on the right-hand side of 18. On the left-hand side of 18 is dy or the change in output. dm refers to the change in money stock or the change in money supply. The change in money supply by 1 unit will increase or decrease, dy here or output by the amount of this term. The amount of this term is referring to multiplier for changes in money supply. Now, the multiplier for changes in money supply here, you can see dP. That means we allow price to vary or price is flexible. What if price is fixed? Then the whole term here won't exist, isn't it? Because dP is 0 when the price is fixed. Okay? That means multiplier for changes in money supply when the price is fixed must be bigger than the multiplier for changes in money supply when the price is allowed to vary. So what's the implication of this on the monetary policy? Similar to the previous analysis, when the price is allowed to vary, the implication on money supply, increase in money supply on income, or the implication of monetary policy on income or economic growth must be smaller than when the price is fixed.